Well, now we come to analysis of group second. As we have seen, the group reagent for this group is H2S in presence of dilute hydrochloric acid. Suppose on adding dilute HCl to the salt or mixture, any precipitate, that means first group is absent. And if a white precipitate is obtained, then first group is present. We will filter that precipitate and pass H2S gas into the filtrate or directly into salt plus HCl solution. There if we get a precipitate, that means second group is present. We shall filter it so that filtrate will be used for third group and the residue precipitate for second group. The precipitate obtained on passing H2S will be collected and dissolved in yellow ammonium sulfide, that is represented by the formula NH4 whole twice SX. If the precipitate remains insoluble, it belongs to second A, and if soluble, then to second B. Following is the scheme for analysis of second A group. So, in second A group, initially when we get the precipitate by passing H2S, it can be any one of these or all of these or any 2, 3, any number depending upon the type of radicals present in the mix. So, if it is HGS or PBS or Bi2S or CuS, then the precipitate is black. If it is cadmium sulfide, then the precipitate is yellow. We collect the precipitate and dissolve the precipitate in 50% nitric acid with heating and then filter. The residue will be mercuric sulfide HGS because it is not soluble in nitric acid. And the filtrate solution will contain lead nitrate, bismuth nitrate, copper nitrate and cadmium nitrate. So let us first discuss filtrate. To this filtrate solution, we add dilute H2SO4 plus little ethanol and then filter. Residue of bismuth hydroxide, a white precipitate. As shown in the chart, we take this residue and dissolve in dilute HCl. So we get a solution of bismuth chloride BiCl3. We divide this solution into two parts. To the first part we add NaOH plus Na2SnO2, that is sodium stannite. As a result of this, we get a black precipitate of bismuth. We can say finely divided bismuth. That confirms the presence of bismuth in the given salt or mixture. Another test for bismuth is, we take that BiCl3 solution and add water to it in excess of amount. That solution becomes white turbid due to the formation of BiOCl. So, by any of these two, bismuth can be confirmed. So, by any of these two, bismuth can be confirmed. Let us now discuss another residue that was of lead sulfate. We can dissolve this lead sulfate precipitate in ammonium acetate. PbSO4 is soluble in ammonium acetate. Then we divide this solution into two parts. To one part we add potassium iodide. Then we get PbI2 yellow precipitate. We add more of Ki, that is Ki in excess. Then this yellow precipitate is dissolved, forming a soluble complex of lead, that is PbI4 with 2 negative charge. To another part we add potassium chromate. So a yellow precipitate of lead chromate will be formed, that is soluble in HNO3 as well as in NaOH. So by this, lead can be confirmed. For confirming the presence of mercuric ions, we now deal with the first residue of this subgroup. It was that of mercuric sulfide HgS that gave us a black precipitate. Dissolve mercuric sulfide in aquaresia, so we get HgCl2 solution. To this solution we add SnCl2 in excess. As a result of the reaction we get black grey precipitate of mercury.